So basically, I'll start with basic core Java points. Okay. We are going to start Spring Core module. We'll be starting with Spring Core module. As you know, right? After Spring Core module, I'll start the Spring Boot. In this Spring Boot again, I will cover all Spring Core annotations and Spring Jdbc, Spring ORM, Spring AOP module, Spring Web, and Spring REST I will cover here. And apart from this, there are many uh, additional supportive starters we have, that all we will discuss here. In this core module itself, we will see all the starters, built-in containers or embedded servers, configurations, profiles, a lot of concepts we have here. That all will be covered here. Hereafter, we'll start with microservices. Okay. So here we will discuss all the challenges and solutions, design patterns, then Spring provided libraries for config servers, gateway, load balancers, and for resilience for J, we have resilience for J, like historics, and what else I have presented, right, in the paint. Okay. And anyway, this tracing, all these are very important. Tracing, logging, how to handle, etc. We can see here. Distributed transactions also we can try, but that's a little difficult concept. But yeah, we can cover them. Now coming to Spring Core. This is the base module or foundation module, you can say. Spring Core is the foundation module to learn anything. Why this is foundation module we call? Because whichever concepts we learn here, using the same concepts, we will implement other modules. And the Spring Core is having containers. When you learn Spring Core module here, importantly, what we learn is Spring containers. We learn about Spring containers. So you should learn about these containers to understand how Spring applications will work. The main responsibility of these containers is object creation, dependency injection, and lifecycle management. Okay, we'll go in depth into them. But why someone should create object and maintain it? Let's understand about basically object in Java. What is the purpose of object in Java before even jumping into Spring? I have something that I want to store it into computer or database. In front end, I have some fields. I want to store that data into database. Something employee registration I have, name, email, address, and one submit button I have here. When I want to save these fields, which are name, I enter here, email, address, When I want to store it into database table, I need a middleware here like Java, who can read from front end and store it into database. Who can read from front end and store it into database. Before transferring into database machine, here this is your server, or you can say your machine or computer. There you have your program. So this program, whichever program you write here, whichever program or code you write here, this code should able to hold these values temporarily. Name, email, address values. Once it receives, temporarily it should keep in this code itself. Once it transferred to database, this temporary memory can be cleared. So that is what we call object in Java. Let's say if name, email, address, if you are submitting, I want to hold them into a student object. I have a class called student, In that student, I have variables, name, email, address, along with some getters and setters. Private variables, public getter setters if you consider, or else a simple name, email, address variables I have here. So if you want to store this data, into this object or into this class, what you need to do, you have to create an object. Student, std equal to new student. And using this object, whichever object you created, this object will have temporary memory in your JVM. Once you create here, one memory will be allocated. Memory allocated in JVM. JVM again is nothing but your RAM. Okay. JVM is your RAM. Okay. So once your object is created, one temporary memory will be allocated into the JVM. Then you will set your parameters. Student dot set name, whichever name you enter from there. Pragnya, if you enter, you can add that here. And email address. Remaining parameters also you will be setting here. So all these fields temporarily will store into JVM. Who created this object? You created it. During your coding, you created it, and dynamically you are reading these values somehow by using request object, request dot get name, get email, get address. So whichever data entered in the front end, that will be stored into this object, and it will be stored finally into database by using Jdbc something. So manually you are creating this object here. Manually you are creating this object here. Manually you are doing it here. As a developer, you are doing it here. Instead you doing, if somebody do this job, right? Instead of you doing it, if somebody do it for you, this object creation, we call it container. This object creation, instead we doing, if somebody do for us, we call it as container. But end of the day, what they are going to do? They will create objects for you. A kind of little bit automation, you can say. Every time instead of a developer configuring these objects, from here, right? Step by step, we will see full automation. In core Java, how we create objects. We will handle with the objects, whichever constructor I want to call, or method I want to call, or variables I want to call, or setters or getters, or static methods. For everything, we create object and we handle it. But from now here, we will see a container will do it for you. From now here, we will see a container will help us to do that job. Basic object creation. Why a container should handle it? Can't I do it? You can do. You can do, even container also can do. When container do it, when container do it, as this is predefined implementation by experts, right? They handled in a different way. Objects creation, they handled in a different way. Instead of creating millions of objects, containers based on your requirement, they will create less number of objects so that it will occupy less memory in your JVM. It will help you to improve your application performance, right? If you install a lot of apps in your phone definitely will hang because out of memory. Same way, if you create unnecessary of objects, your server will hang or may not perform well. Again, you need to restart servers or you need to increase the RAM. So gradually, whichever RAM you increased, that one also will be occupied. So we can't increase it anymore. So instead, if you maintain good objects, good object creation structure, it may not eat much memory. So that's where these containers will handle it in a different way. So the object creation job, we leave it to container. How containers will create? If we do this way, right? If we do this way, this is a kind of compile time objects creation. Generally, objects will not create at compile time, but at compile time, you are assigning the object student std equal to new student. But containers will create objects during runtime. So to create objects runtime in Java, do we have support? Instead of putting this way, this is like a hard coded way. Student at std equal to new student. Always this statement will be remaining same. It will not change. If you want to change, you need to edit the code and you need to change. But if you have a feasibility to pass this at runtime, can we do that in Java? Means yes. What is the advantage if I do it at runtime? Runtime polymorphism we can achieve. I don't know how much you aware of the runtime polymorphism in Java. What is the basic way, static way of object creation or runtime object creation means when you create a static way of object creation, runtime polymorphism not achievable. Runtime polymorphism not achievable. When you do it in runtime, runtime polymorphism is achievable. Runtime polymorphism is possible. What is this runtime polymorphism? You know, in Java, parent object, when you do it in static way also you can do, but repeatedly you can't change it. Always you do code like child new c equal to child only. This is how you will create. But when it is runtime polymorphism enabled, you can create parent and at runtime you can pass any child, new child one. Or tomorrow I don't want this child dependency. I can move to child 2 or I can move to child 3. What is it? What is all this nonsense? Is it really required to change childs? Yes. If you consider your application like a car or a phone, in phone, how frequently we change SIM cards? Few people will change, right? If we don't want that particular SIM on our phone, we will remove and we'll insert new SIM. That's how phones designed. If car tires got damaged, we will install new tires. They will allow to install. That's how cars designed. If cars were not designed to replace the tires, once tires gone, car also for no use. Will they do really like that? Yeah, like CDMA phones, if you see, 20 years back, we don't have this GSM mobiles. CDMA phone, whichever SIM card they will provide in that phone, only that SIM we need to use. We can't change it. If you don't want it, you need to throw that phone away. That's it. But nowadays, all are GSM. You can buy any phone and you can buy any SIM and you can pair them. So this runtime polymorphism advantage, if we utilize, it will allow our code to behave independently. Otherwise, your code will be tightly coupled. So to achieve that, this runtime polymorphism is very, very important. But how we achieve if we want to replace new child, instead of hard coding what we do, instead of hard coding what we do, this is how we create parent equal to class dot for name concept we use. In this class dot for name, pass this value from runtime arguments, maybe from arguments, right? Argument is 0. Pass whichever class name you want. Dot new instance. Whichever argument you pass properly, if that argument belongs to this parent, this class dot for name will create object for you. It will create object for you. So today I used in 0 argument child 1. Tomorrow I don't want child 1. You can pass child 2 or you can pass child 3. Application continues as usual. You may get doubt here. If I am using child 1 functionality will execute. If I use child 2 functionality may be different. Yeah, that's where this runtime polymorphism giving us advantage. Whichever methods there in the parent, those methods only we will implement in childs. But in that methods, you may show some variations or improvements or advantages. So the new advantage child we can add that can be utilized in our application. So just by using this simple concept, Spring came up with on top of this, right? This is the main key for any framework, which is dynamically creating objects, right? Using this line, class dot for name only, they will do. This is the main key for any framework. Class dot for name is the main key for any framework. Using this key only, they created frameworks. Okay, now coming to Spring. Spring also will create objects. Using what? Internally by using this kind of statement. We are not going to write all this. Spring will do, Spring core internally will do that. Whichever Spring containers we have, right? They do that. Okay. So the main purpose of a Spring core is first thing object creation. For which classes it will create objects, sir? First purpose here we will use. Let's learn about bean, okay? Because every class we call it as a bean. Bean means don't confuse. Bean means a simple Java bean class. No. Any class we call it as a bean. Any class means can be your controller class. It can be your service class. Controller means who reads data from front end. Service means business code. There we write the business code. Repository class or DAO, which have database operations. Okay. And apart from this, you can have utility classes. The application will have controller, services, repositories, utilities. Apart from that, you can have DTOs and entities. You can have DTOs and entities, data transfer objects and database entities. So this type of classes you can have throughout the application. Any application will have controller, services, repositories, utility classes, DTOs or entities. We call them bean. We call them bean. Let me again explain through. Don't confuse. After this, class dot for name, why I'm going to explain you bean. I'll conclude it, okay? In Spring, whichever you write, we call it as bean. Let's say I have a requirement, as I said, right? I have an employee registration form. For this employee registration form, I want to implement code in Spring. Yes, you can implement it. We write controller class. We write a controller class. Then we write a service class. And we write a repository or DAO class. DAO class here. And whichever data coming from front end, we populate that data into DTO, data transfer objects. Of course, these DTOs we will utilize inside controllers. Whichever post method you have inside that post method, using request body, we'll put a DTO. So whichever data coming from there, front end, it will be populated into DTO. We send this DTO towards a service. We send these DTOs towards a service. So service will get that DTO, whichever business method you have. Let's say create employee or create student method I have, sir, here. Yeah, we'll take it as an input, DTO input. And the service will send this data after populating this data into entity. DTO's data, it will populate into entity. Entity is always mapped to database. In ORM, you will understand that, okay? Entity is only for database purpose we will use. So that entity will go here, whichever save method you have or update method you have or delete method you have. Entity method. So here we will do CRUD operations by using, if it is a Hibernate session dot save, we call and we pass this entity reference. And it will be saved into your database. Why you are telling this story, sir? I'll come to the point. So finally, it will be saved into table. This is how MVC, by following MVC architecture, we write code in Spring or in any framework. Now coming to Spring, whichever controller you have created here and service, DAO. Every class, as I said, right, every class we call it as a bean only. Every class we call it as bean only. So now whichever classes you have created here, all these classes objects will be created by your Spring container. We call it as IOC container, Spring container. Okay. So this Spring container will create these objects. When you create this application, right? Who will create objects for these classes? Spring container. How many objects? By default, Singleton objects. For controller, one object. For service, one object. For DAO, one object. Who will create? Your Spring container will create. So from here, let's say today one university opened applications. So a lot of people, like 10,000 people or 1 million people are applying for it. 1 million people are applying here. When 1 million people hit this application, will 1 million controller service DAO objects it will create? End of the day, all these will be loading on JVM only. If you do manual object creation of this controller service DAOs, 1 million objects you are going to create in JVM. Literally 1 million. This 1 million objects may need at a time if you get that many requests. If you don't have perfect thread handling or object handling, you may need here something around, no, just I'm giving a sample, around 50 GB or 100 GB of RAM you may require here. Is it possible to provide that much RAM this may not continuously using. When university opened for applications, only this much memory is required. Is this much memory can be maintained in a machine? No, impossible. Maybe hardly you may have 32 GB or 64 GB. That to high-end configuration machines if you have. How to handle such scenarios? Even though I have 1 million or 10 million or 100 million object requests from there, that many controller service DO objects are not really required. One object is enough. For each one object it will create. So overall for 1 million request in JVM, instead of creating 1 million objects, Spring container will create only 3 objects. 3 objects only it will create. So your RAM is free now. It will utilize that RAM for to store temporary data of DTOs and entities. As I said, right, when you submit something, that data we will store it into these such bean classes. So that particular memory it will use for these beans. Those are also temporary. One DTO object will be created for every request and that will be cleared automatically. Same way entity. And as usual, you are going to use a server here. Server will handle that traffic. Maximum, even if you get 1 million requests, it may not allow at a time. It will keep them into hold. Tomcat will create a queue, temporary queue. Via that queue, it will process all that request. So as application will not get that much load at a time. Tomcat will create a queue and it will pass them whichever maximum request we can handle application side, right? That many only we will get, hardly maybe 1,000 requests or 2,000 requests per second. So your application peacefully will handle that request and complete it. JVM also will be free as your main object like controller services are holding only 3 objects memory instead of 1 million or 10 million. So this is what we call singleton. This is what we call singleton objects creation. Who do this? If this responsibility we take, we need to spend lot of time to handle such techniques. Only the singleton technique Spring container is giving or overall Spring is providing means no. Such type features like internally thousands of features Spring container is providing. Right? This is a framework designed by experts. Designed by experts. So when I use that framework, by default, all that experts given solutions by default applied to my application. I am not an expert, but my framework is a expert framework. If I use that, by default, whatever 1,000 good practices or 1 million good practices I have in this framework, that will be applied to my application. Okay. So when I use Spring, by default, it will create one single object only. How it will create, that we will see. Right? Practically, we will see how it will create. As I said, right, any class we consider it as a bean. Either you say controller, service, repository, util, or your DTOs and entities. How container will create objects, sir? For example, I have a class student, a simple class with the constructor. In this constructor, I have system.out.println. Just I want to show you objects creation. First example, how Spring create object. This is the first step that we need to learn. So I have a class here. For this class, I want to create objects by using Spring. System.out.println. Right? If anybody wants to create object, they should call constructor. This is constructor. Student constructor. Without constructor, object is impossible. So you create it or some other create it, they should call this constructor. So when you call constructor, inside constructor, I have this code. So this code will be executed. So you can see this output statement. What I should do next, I created a class. Next thing is you need to create one Spring XML file. XML. In this XML, there is a main tag name called beans. There is a main tag name called beans. Inside this beans tag, there is another tag name called bean. Using that bean tag, using a class attribute, you need to give this class name here. That's it. XML is done. What should I do next? You need to create one test class. Test means not JUnit, a simple main method class. Class test public static void main string args this is where actually we load this XML. Here I have XML. First I created a class. This class configured in this XML. Now this XML is going to load it into container. The container name is application context. AP equal to new class path XML application context. Here we load our XML file. That's it. When you start this main method or when you right click and run as main method, this line of code will be executed. This line of code will be executed and it will create object. It will create object. Student object will be created. Who creating this one? This is the container. Sir, you are showing a simple Java class and you are saying it as a container. Yes. Spring framework given container as a simple Java class only. Earlier containers are softwares like Tomcat, MySQL. MySQL is not container, but example. Those all are separate softwares. Those softwares used to behave like a containers. WebLogic, JBoss. We have to place our code there. Then they will create objects. But Spring made it as a simple Java class. They gave in to us like a Java class. Just you can create this class object. If you are creating this class object means you are starting Spring container. This is server. Server came as a Java class. Spring container came as a Java class. Just you need to create object for this Java class bus. Load this XML. It will take care of all other classes here. How many classes I can have in the Spring XML file? Any number of. Based on your application, hundreds or thousands of classes you can have. For all the classes, this single line is going to create objects in one line. All objects will be created. What next? We will see them. Okay. I'll show you this example. So from where I can able to practice or see these examples, I'll give you this link for Spring Core only. Okay. This link I am sharing you here. This is our blog only. Okay. This is our blog only. So you can download JARS here at first step. Okay. You are able to see this, right? Guys, am I audible?
Yes, Naveen, you are audible.
So first you have to download this. Just sir, why you are telling download all these and do practice just for timing, okay? Until you understand basic Spring Core module, you know, do these examples. Then we will go to Spring Boot. There, nothing you do manually. Everything via Maven we do, okay? For now, just for next few sessions, do old style practice. If you click on this jars download, it will give you jars. It is downloading all Spring jar files, you see. Basic Java runtime object creation also I have given. You can see that one as well. Okay, anyway, I just need jar files. That's it. You can use Eclipse or STS. Anything is fine. I'm in STS now. I'm creating a simple project, Java project. Okay, you can see step by step. Anyway, this recording also will be available to you. Project, Java, give some name here. Spring Core, Java 1.8. Enough for me for now. Finish. Okay, I created one simple Java project. First step, what I will do here is I will add this library. Spring library I have here, right? Extract. Just unzip all the library. You can see a lot of jar files I added here. Directly you don't get them. Okay. So you can download from this. From internet, you will not get all of them in one go. You can download them from there. So go to build path, configure build path. This is old way of coding. Why should I learn these? Yeah. Nowadays, I'm seeing people who don't know all these. They are struggling. When I say, yes, sir, I'm not able to compile in my machine, in my office, also people say, I have problem with so and so jar. They should able to, at least in local, they should be able to add these jar files manually. They should able to test their code, but they don't know what is this build path, adding libraries. These are very, common basics only. Okay. Yeah. So now create a package, beans, add your Java class there. Already we have class here, right? Just go and add it. Go and add it. Yeah, this is my Java class. Hope it is visible, right? So inside package beans, I have public class student with the student object created on output statement. Now create one package called resources and place your XML file. So this is XML file structure you can see. As I said, right? This is a main root tag beans. Okay. So this is the main root tag. Inside that root tag, you need to configure your bean. What is my bean class name? Student. Student inside beans package. Beans dot student. Beans. Correct only, na? Yeah, beans dot student. Right. So the path is correct only. Now load this class into your container. Let's have a test package and write a test class. Main test. Main method. Type main control space. Automatically it will generate main method. Then application context. AP equal to new class path XML application context. Here you can pass resources slash test.xml. Bas, you are done. Right click, run as a Java application. Student object is created. See this? Nicely, one object is created. Run again. Student object created. Who created? I didn't create it. I don't have any new keyword with the student class name here. But instead, I am doing it. This test XML file configuration, I am loading into this container doing it. So though you utilize this class for 1,000 times also, only one object. As this container creating Singleton object, it will create only one object. Let's call that class for 100 times, get bean student class. We can ask this way, container, please give me student object. It will provide to you. You can ask container. You can ask container, I need that object. Okay. Container will provide you. I'm calling it for many times. 2, 3, 4, 5, 6, 7. 7 times I'm calling. But object is one only. So this is what we call singleton. My container creating only one object. Instead of creating multiple objects for these classes, it is creating only one object. Singleton object. Generally, we use only singleton mechanism only. Here, if you request it for 1,000 times also, one object only it will provide. Here we have scope attribute. If I put the scope equal to prototype, then it will create many objects. 7 times you call, right? 7 objects it will create. First, second, third, fourth, fifth, sixth, seventh. I have 7 objects. Why this many objects it is creating? As you mentioned it here, prototype. By default, it is singleton. By default, it is singleton. If it is a singleton, only one object. If it is a prototype, as many times as you call, it will create that many objects. So that is the beauty of container. Instead, we creating objects, if we leave that responsibility to the container, for your classes, it will create only one object, right? So in real time, if you see food delivery applications or online e-commerce applications or banking applications, at a time, millions of users, they will hit applications. If those applications create prototype objects for each user, one new object if they create, then that application performance is gone. It will not work. But instead of prototype, every application will follow singleton mechanism only. One object, enough, bus, no issues. So who is handling it? Your container is handling it. I am not doing it. Container is doing it for me. So there is a container which is helping me to do that. Instead, I am doing, container doing it. If I do it, lot of code, I need to write thousands of code, thousands lines of code. But Spring Container doing it on fingertips. Simple. Just create your classes, put it in XML file and load it here. So when you go to Spring Boot avoided this XML based configurations also. Nothing. You have to create classes. That's it. Automatically, Spring Container will scan all your packages and it will create objects. That's a different story. As I was saying, right, in the initial discussions itself, Spring Boot is a automated framework. Everything is automated. Okay. So yeah, this is the first thing that we need to learn. What is the bean class and what is Spring Container, what it is doing. So we just understand from today's session how to create object, how Spring creating objects, how Spring create objects, how Spring create objects for any class. We generally call beans. Beans means don't consider like simple Java class which is having setter getters. No, beans means any class. Your controller, service, DAOs, everything. For all your classes, it creates objects. So far clear? Sandeep, Pragya, Kalyan.
Yes, Naveen. It's clear from my side.
Yeah. So what I request you is today, post this session, download Eclipse tool, Eclipse or STS. Go with STS. I prefer STS. Okay. Download STS. If you want, I can share you link. Spring Tool Suite. Official Spring Tool Suite. You can download here. Not Visual Code Studio. This one. If you are using Windows, using this Windows. If you have Mac, you can go with Mac one also. Download STS. And whoever is new, right, just join this WhatsApp group. Yesterday I shared a link where it is. Yeah, please join this WhatsApp group. If you click on this link, it will allow you to join there. Okay, please join this WhatsApp group. If you have any questions or if you miss any links or references, you can ask me. Okay, download this STS. Once you download, go to this blog. Okay, go to this blog. You can download these libraries and examples. Like how I shown in the video, right? You can write the code and practice it. This video, I think they will upload maybe in next 1-2 hours into YouTube. Okay. So those demo links also you will get. Anyway, once you confirmed, right, these videos will be shared to you Google Drive also. Okay. Any doubts? Any questions? Kalyan, Sandeep, any comments? Yeah. If we are good, we'll close for today. We'll continue the session tomorrow. Okay.
Yes. Thanks, Naveen.
Yeah. Thank you all. Have a good day.